Hey guys, in this video I'm going to be teaching you how to complete the square when our a value is greater than 1. So we'll learn via example. For the first example, we're just going to practice rewriting it. So one type of equation or problem I could give you is rewrite in vertex form by completing the square. So our equation will be y equals negative 2x squared plus 8x minus 3. Now, the first step is going to be the same as it was when a was equal to 1. And that's going to be to move over that c value. So we want to take that negative 3 and move it to the other side. That y is still going to be there because we want y to stay. We want to end up in vertex form, so we need a y equals. So now that I've moved over my c value, because we have an a, we need to factor it out completely. So we are going to factor out a. So it will always, here, I'll write steps. So move c to other side. And then we want to factor out a. And then that way we're left with a times x squared plus whatever b divided by a is. So in the actual problem, that's going to be that negative 2, so we have y plus 3 equals negative 2 times x squared, and 8 divided by negative 2 is negative 4x. Now is the part where we complete the square. So remember, completing the square will be exactly the same as it was when a was equal to 1. So it's going to be b over 2 squared, which in this case, this is now our b. So it's going to be negative 4 divided by 2 squared, which is equal to 4. So this is where it's a little bit different. We do want to add to both sides, but we have to be very careful. So on the right side, I'm going to have negative 2, and then I have x squared minus 4x, and then I'm going to have my plus 4. And this, remember, is coming right from here. However, when I add it to the other side, it's not 4 on the left side. It's technically 2 times 4. So on the left, I'm going to have y plus 3 times negative 2 times 4, which is negative 8. So when you complete the square in the parentheses, it's not the exact same number that goes on the opposite side. And then from here, it's pretty straightforward. You just simplify. So we do 3 minus 8. Which is negative 5. Our negative 2 stays on the outside. We factor what's in here, so x squared minus 4x plus 4 can factor to be x minus 2 squared. And then it's almost in vertex form. We simply need to move that 5 over. And we are done. If I asked what the vertex is, you'd be able to tell me it is positive 2, positive 5. So let's do one more example, and this one will be a solving problem. So we want to solve for x if our equation is negative 3x squared plus 12x minus 25 equals 0. And if it equals y, we would just start by setting it equal to 0. So same first step, I'm going to move over my 25. So we have negative 3x squared plus 12x equals 25. Now, because I have because I have an a value, I need to factor that out. So I'm going to take out my negative 3. I am left with x squared minus 4x equals 25. And now I complete the square. So negative 4 divided by 2. Oh, that's funny. It's the same b value. So that's going to be positive 4. But this problem is actually different. So on the left side, I bring down my negative 3. I still have x squared minus 4x. But then inside our parentheses, we've got plus 4, because that's what completes the square. And on the right side, we have 25, but we're not going to have 4. We're going to multiply negative 3 times 4. So we will subtract 12. And now we factor and simplify. So we have negative 3 times x minus 2 squared. And then 25 minus 12 is positive 13. And now I'm solving, which isn't going to be crazy nice, but that's okay. So I'm going to start by dividing by negative 3. And I get negative 13 thirds, which we are going to leave as a fraction. And even though it's negative, we're still going to take the square root because we have learned about complex numbers. When you take the square root, remember you're doing both the numerator and the denominator. So we get x minus 2 equals plus or minus, the square root of negative 1 is going to be I, and then we have root 13 over the square root of 3, which technically in this problem I guess is a little bit harder than what I might give you. But our denominator is not real, so we should rationalize it, if you remember that from Algebra 1. So it's similar to when the denominator is I, we multiply by root 3 over root 3 to get rid of that radical. And we get 13 times 3, which is going to be 39. And then the square root of 3 times the square root of 3 will be the square root of 9, which is just 3. And finally, I just need to move over that 2. So it's going to be 2 plus or minus I root 39 over 3. So a little bit more challenging because of the rationalizing of the denominator, but altogether not too bad.